One of the things that's important for us to be able to do in the Linux environment as we're developing code is to import it into an integrated development environment. So code, our .c and .h files or .cpp files if we're working with C++, we want to be able to take those raw files, bring them into a project structure so that we can work with them in an integrated development environment. The integrated development environment we're going to be talking about or using here is the Eclipse CDT tool. This is probably one of the most common tools for developing Linux code. It can be used in other environments and can be set up quite extensively to do what you want to do with it. So what I'm going to do is demonstrate with a very, very trivial Hello World type program how we import the code, select the C files, set the output, generate our make files, and set up our artifact type so that we can actually compile a project. Now the project we're going to bring in lives here in this folder Workspace Demo1 Source. So source is the source code file, Demo1 is the name of the project, and it's the workspace where the multiple or the set of projects are going to live at is going to be called the workspace one. Normally you have much more meaningful names than I've got here, but these are just demonstration names. So what I want to do is start Eclipse up now. And Eclipse will take just a moment to get started here. And when it starts up here, the first thing I need to do is select the workspace. Now this is pre-selected here to /home/cs3841/workspace. That is essentially the set of projects I'm going to open up. Typically you can have as many workspaces as you would like. For academic settings, typically you can have one workspace per class, one workspace per project where you might have multiple iterations of the code, different flavors that you can do with workspaces. Within the workspace, then you can have as many projects where each project is an individually compilable unit. So I'm going to open up Workspace 1. This again will take just a moment to go through and to parse Workspace 1 to find the projects that may exist within it. Right now we're going to find that this will open up with essentially nothing because there are no projects in this workspace right now. I need to reconcile that here. So here you see again, as I said, no projects in the workspace. There's nothing I can do with this. So to import this code that is living actually right now inside of this workspace to some extent, what I need to do is go over here and I want to start importing, in our case, existing code as a makefile project. Now, existing code as a makefile project, what that's going to do is create a project that has a makefile that will build the code, and it's going to allow us to use this existing code. Now, this code may come from an external repository, a GitHub repository. It may be something that you share with someone. It may be mounted externally. Lots of different places that this code can come from. So I want to import this in. And the project name, in this case, is going to be this name that I have here, which is going to be Demo1. And then I want to browse to the existing code location. So, Workspace 1, Demo1. Now notice I am not going to select the source folder. The source is where the source code actually lives. I want to select the project that is one higher than that for right now. I also want to set this up to use the Linux GCC toolchain. Now the GCC toolchain, that is the toolchain that will compile for Linux. Cross GCC will actually cross-compile for a different environment. So for example, if I was developing for BeagleBone, Raspberry Pi, something like that, I could do the same general task that I'm doing right here with setting this for cross-compiler and then compile to those environments. Okay, so I've got this. I'm now going to click on Finish, and we will see that the project has been created here, Demo1. I have the source directory, and then I can browse and click on my particular files here. So here I clicked on demo1.c, for example, and it will eventually open up here. And we can see this is the same that I had before. The beauty of this is in the integrated development environment, I can minimize these things. I can hover and bring comments up. Lots of different things to make my life a little bit easier to develop things. Okay, so the project has been imported. Now what I need to do is set up the directory that's going to be my output and essentially where my source code is so that the make file is actually able to generate things properly. So to do that, what I want to do is select my project, right-click on it, and go down to Properties here. And actually, I forgot. I want to do one thing first. Before I do that, I want to create a new folder here that I am going to call Debug. And that is where my output is going to get placed at. So I go here. Now I go into CC++ build. Whoops, CC++ general. Excuse me, wrong tab. Paths and symbols, which is right here. And I want to select my source location. So I'm going to add the source folder as source. And when I do this, you'll notice this is kind of just a plain folder icon right now. You'll see that change here in just a moment. And I want to remove demo1. Apply this to the project. Notice how this has that little C indicating that's now a compilable unit. My output location, I'm going to add this into the debug folder like so. And again, doing the same thing, deleting the other folder. So I have created this, set things up. Includes symbols, libraries, library paths, those types of things are things we will address later on with other projects that we don't need right now. So I'll click on Apply. I want to then go up to the C build and indicate that I want to generate the makefiles automatically. Click on Apply as well. And last but not least, I want to go to the C build, the Settings tab, the Build Artifact, and I want to say that this is an executable that I'm creating. It is possible that I could create libraries and do other things with it. I'm not going to worry about that right now. So I've got this all created. I click on Apply. My project now exists. I can do a build all of it. We'll see it's building the project. The makefile is building, like so. We invoke the linker, and we created a project demo1. I can then take demo1 and run this as a local C application, like so. And you can see it says Hello World. I can also take and set up debug environments and things like that in my project as well. So okay, this is all set up. The other thing that now I have the ability to do since I've created this, you see that in here we have a actual makefile that's been created. I can actually build this code now on the command line console. So let me open a terminal right here. And I'm going to list the files that exist here. I can do make clean, make all, like so, and actually build right down at the command line console. And then I can also run my result here down at the command line console by clicking demo1. So now that the project can build and that we can run it both from the command line and from the tool, we might also want to debug it. So what I can do is I can take my environment here, selecting my executable program, right-clicking on it again, and I can do a debug as a local C++ application. And what you'll see is this will start, and it will pop up a menu here momentarily saying it would you like to switch to a debug perspective, which I just did. Now I'm in a debug perspective. And I can go through here and step over various things. So we can see that I'm malloking some memory space, doing a string copy here to the message. See it got initialized to hello world, printing it out like so, free, and then I'm done. Now, one of the things that you will find when you start debugging, and let me switch back to the C perspective. A lot of the times the development environment will optimize things more than you would like them to. So I'm going to go in here to the project settings. And on the compiler, clicked on the wrong spot here. Settings. Tool settings. So for the compiler, what we want to do is we want to make sure that these optimizing parameters are set to 0. And set this to 0. Now this will make it easier for us to debug our code. So at this point, we've shown how you can import code into Eclipse, how you can set up the C folder, how you can set the output, generate a makefile, set up your artifact type, compile the code down from the command line console, and do a little bit of very, very preliminary debugging. That's going to bring this tutorial to a close.